the misbehavior of spatial rotations. So the exercise is to perform a 90-degree rotation about the z-axis using only rotations about the x and y axes. So we want to get to this orientation using only x and y rotations. So as you do this, make sure you note down your steps, because that way you can repeat what you've done and actually find a procedure. So try and do this. Once you have it, we can see one possible solution. So here's one way to do it. So the first step is to perform a 90-degree rotation about the y-axis. So that's going to go like this. Next, perform a 90-degree rotation about the x-axis. So the x-axis is pointing this way, so that's going to go like this. And finally, we'll perform a negative 90-degree rotation about the y-axis. So since it's negative 90, positive 90 is like this, negative 90 is going to be like this. So we end up here, which is indeed the same place we would have gotten if we had just done a 90-degree z-rotation to begin with. So this is equivalent to performing a 90-degree rotation about the z-axis. So as an extra challenge, can you perform a 45-degree rotation about the z-axis using just x and y rotations? And if you can do that, what about an arbitrary theta degree rotation, where theta could be any angle? So you can, it turns out, and in fact something even more interesting is possible, because we'll soon see that x, y, and z rotations are entangled at an infinitesimal level. So are there other surprising behaviors of rotations? Well, let's take a look at some other properties. So why don't you try the following? Take out your puppet and first perform a 90-degree rotation about the x-axis, and then perform a 90-degree rotation about the z-axis. So what do you get when you do that? Well, an x rotation, if you look at the picture here, will take you to here. Using the right-hand rule, we've done a 90-degree rotation about the x-axis. Now if we do a 90-degree rotation about the z-axis, we get to here. So this is an x rotation followed by a z rotation. Now let's do the reverse, the opposite order of operations. Let's perform a 90-degree rotation about the z-axis, which is going to take us to this state, followed by a 90-degree rotation about the x-axis, which will take us to this state. So we are clearly in a different orientation now than our first sequence brought us to. So what exactly happened here? Well, the answer is that rotations do not commute. The order of operations matters. Okay, so that's the second property. Now there's a third, even more basic property I want to mention, which is that any 360-degree rotation will take you back to where you started. Will take you back to your original orientation. And that's almost too obvious to note, but it is important to mention because it shows us one more way that rotations, the way that rotations take us through the set of orientations, is very different from the way that translations move us through the set of positions.